just to highlight that this is a review that me and a few of my colleagues wrote in Drug Discovery Today, and the talk is loosely based on the paper that we wrote. It's in press, so it should come out soon. I'll give you a background of what I'm going to talk about. The FAIR journey at Roche. Genentech is a member company of Roche. And how FAIR and data quality do they intersect? If not, what are all the factors that we should consider for making good use of the data that we produce? And I will conclude after that. A few years back, 2019, the Novartis CEO made the statement, and I want to highlight the sentence here that says that's just cleaning the data sets before you can even run the algorithm, and that has taken us years just to clean the data sets. I want to use that as a hook for my entire presentation, that cleaning data sets takes a lot of time, and the previous speakers have all alluded to that, and turns out that we all spend a lot of time cleaning data sets before we can glean any insights from the data that we produce. So since I'm from a pharma company, bulk of the things that I'm going to be talking about is clinical trial data. And there are some things that are very obvious. We spend a lot of money, everybody knows that, to set up a trial, to collect data, work with various sites, the clinical trial sites, to set up the electronic system to receive the data and so on. We spend a lot of time and money in procuring and managing patient samples. We spend a lot of money to run very high dimensional assays, whole genome sequencing, and flow cytometry, and those sorts of things. And then what is not obvious is how much variation is there in the data that we receive, how much infrastructure we need to put together to bring this data together, and how much work we need to do to bring it to conformance and cleanup and so on. And what also happens is, once a clinical trial is, a study is over, and depending on whether it was positive or negative, the data set is put away, and we move on to the next trial and so on. So if we are investing so much time in acquiring data, we should invest enough time to make sure that it's good and we can reuse it again and glean some insights from this. And this has driven us, meaning Roche, to a new project to make data management practices better, so we can do reverse translation. Reverse translation is essentially, you have a clinical trial, you've collected data, it was positive or negative. Either way, you gather insights from that data or that study, and then you feed it back into the research and development. And you either develop a good drug, a different drug, a better drug, or you figure out how to do your clinical trial better, how to recruit patients better, how to do a study faster. Do we really need to wait 3 years to do a readout for a study, and so on? So these are some of the questions that come up, and we have all seen in this pandemic how important it is to gather data for a clinical trial, and make sure that it is actually good, and whether the data was, the trial was run on enough number of samples, enough number of people, was there enough diversity in the trial, and so on. So there's a lot of inherent or invisible information that these studies and data can give. And how can we make this more seamless? And that's the triangle in this picture that you see in the middle. How can we improve our data management practices? How can we integrate the data that we bring from various sources? And what can we offer a single point of truth, what we call a spot internally? So all the scientists and analysts across the company can access this data and make use of it to gather insights. So we started out a FAIRification initiative in 2017 in Roche. It's a multi-year program. It's a collaborative cross-pharma effort. What I mean by that is we have different business units in the company. Many of you probably are very aware of this. And we make sure that we are all talking to each other, and everybody is part of this initiative. And we are not saying that, hey, you are in research and development, I'm in product development. We all came together and sat down and figured out what needs to happen to FAIRify data. And we worked with the science people, the scientists in R&D, to understand what their pain points are and how much time they spend in understanding or even retrieving the data and putting it together to glean some insights from it. And the last bit is the very important bit, is actually encouraging or inspiring people to have this mindset about think about the data that you're collecting and take ownership for this data and say that I'm going to make this data as fair as possible, and I'll go out and learn what it needs to make data fair. So a whole data citizenship movement, that it's not this data is not just exclusive for this study, and once the study is over I just move on. It's more about this data from this trial is our data, the company's data. How can I socialize this data? How can I make this usable for everybody? So kind of engineer this mindset into everybody that's involved in this process. So these are the four big aspects of this initiative. I will be preaching to the choir here if I have to say what this FAIR principles are. FAIR stands for findability, accessibility, interoperability, and reusability. The main win for this is ability for scientists or the data consumer to find data and understand the data without having to talk to the producer or the owner of the data. So often, I think Shefali alluded to this, you always have to go and ask, oh, you named this column to be name one. What does it mean? What is in this column? And so on. So ideally, you should be able to access any data without having to talk to the data owner or data producer. And what can I do to make the data machine readable so you can run all these fancy machine learning algorithms? What are the implications of making data fair? So what is involved in this? So you can see that I have small icons here that says F1, F2, F3, F4. They're all maturity indicators, and you can find more information about these maturity indicators in the Pistoia Alliance website. I will talk about that in a bit. So what does findability mean? We have a lot of data sets over, our company is very old, over several years we have done clinical trials. And also, as you know, technology has improved, right? Like way back, we had a different type of database, and then moving forward, we have more powerful, different kinds of databases. And some of the data sets were stored as just flat files, some of them have been in databases, and so on. And we are constantly moving and keeping up with technology, and we also have to make sure that we make all the data sets are findable. And how do you make them findable, right? You need to have a good way of maintaining identifiers for data sets, not only data, but metadata as well. And these should all be global, unique, persistent, so none of these identifiers vanish. You should also have like a steady URL, so you can put in the identifier and you know exactly what the identifier is pointing to, whether it's pointing to a study or pointing to a data set within a study, and so on. And the data are described with rich metadata, and it is all registered and indexed in a searchable resource. And believe me, these things were not done in our company. It was kind of a fragmented effort. Not all data were not in one central place, and there was no way to search for them using consistent metadata tags. And for example, people had tagged RNA sequencing data with different metadata tags. Some would say RNA-seq, some would say full RNA sequencing, transcriptomics, and so on. So we needed a dictionary to say that all these are synonymous, and how do you define synonyms, and so on. So there's been a big effort within the company to standardize a lot of things. So that talks about the findability of a data set or data itself. And accessibility is to make sure that the data sets are accessible to anybody within the company. What this means is some of the data sets are kept under a lock because it's either blinded study and you don't want somebody to open it and read the output and so on. And also some of them are anonymized, genomic data is anonymized. And we also want to make sure we know who is using the data set. So we want to make sure that we have a standard set of rules defined for accessibility, And over the last 3 years, internally, we have come up with rules for what data is accessible, what data is anonymized. And even in anonymization, there are different levels of anonymization. And we have tags to mark that this data set is anonymized at this level, and these are the details for this. Documentation is available for all these anonymization methods. The anonymization method scripts are standardized. There is rich markdown for all the scripts and so on. Interoperable, this is like a big part of FAIRification and for being able to do any part of machine learning, which is to make sure that the data itself is interoperable. They use standard ontologies or vocabulary. And lastly, reusable. The metadata and data have correct licenses and usage requirements that anybody can pick it up and reuse it. So in part of this FAIRification initiative, we pursued something called learn by doing approach. We talked to a bunch of scientists and asked them what are there some really big indications or therapeutic areas where you want to use these studies and gather information from those. And they suggested some studies, and they said, can you use these studies, harmonize the studies and give it to us and tell us how you're able to do this. So once they identified a bunch of studies and therapeutic areas, for example, asthma, cancer immunotherapy, Alzheimer's disease, we have several studies in these indications. They identified some of them and told us, can you FAIRify this data? And quickly, a whole bunch of curators and integrators were put together, a team was put together, and we got to work. And we first found that some of the data sets that the scientists are asking for some of the studies we didn't even know where they were. For so many reasons, the people who were involved in the studies had moved on, and there was no record of where the data sets were, or we didn't know who to ask, and so on. So there was a lot of discovering in this process. So here is a framework of how we came about or how we defined these aspects. We talked to a lot of people, found out what is required to find these data sets. And then we said, okay, in the future, if we need to find these data sets or future data sets, here are the metadata tags that we need to come up with to make sure these are findable. We need to find a spot or a location where these data sets are going to be stored, and so on. So for making the data sets interoperable, we decided that we'll just stick with the SDTM model, which is a CDISC defined model. It stands for Standard Tabulation Data Model, SDTM. And we made sure that the data is collected over different points over the years. So although SDTM is the standard model, you can see a lot of variation within the standard model. Although the variable names or the data elements are same in some of them, data within them are different, and some of them follow a code list, some of them don't follow a code list, and so on. So we came up with rules. We just used R scripts to come up with standards to make them all interoperable. So the way it works is we bring data sets together, for example, demography data sets, and then we pool them, then we harmonize. We take each variable in all these data sets and make sure they're all harmonized. And most of it is done using R scripts. And over time, we figured out what all variables need to be harmonized and what are relevant to the scientists. We don't want to boil the ocean. So we talk to the scientists. It's an active, engaging conversation. And we only clean up or harmonize variables or elements that are needed for the scientists. And then we have several quality control checks that we have implemented to make sure that the curated data is done correctly. And then we release the curated data into a catalog. Again, there's a lot of metadata associated with every data set about who did it, how was it done, and the R markdown for the, so if somebody wants to recreate it, they can actually always go back and do that. So this is kind of the infrastructure that we have developed in this initiative. Layer 1 is the basic like machinery and what is the infrastructure that we do. And layer 2 is the scientific data assets where they are, where the data is stored. So we put all the pre-curated and curated data in the spot, layer 2. and we make sure that this layer 2 is visible to people who want to access the data sets. And we also provide a harmonized data access point where data is harmonized, both the clinical trial data and data that was not submitted for clinical trial, they're all harmonized in this spot. And there are tools and visualization tools and analytical tools that are provided in layer 4 and layer 5. And as you can see, we just not only make sure that the data is FAIRified, we also make sure that the APIs that are used to access the data sets across all these layers are fair, are open and fair as well. So what we learned a lot by curating and integrating legacy data sets. So we figured a lot of holes in our processes, and we figured out that this shouldn't be the case moving forward. So we came up with a data playbook, FAIR data playbook document, so that people, so that the study teams that are collecting data moving forward are following this recommendations. So when the data comes in, it's born fair. So a detailed document was launched, and very step by step, the study teams are given guidance on planning, acquisition, processing, and release. And we also have developed several tools to make sure that there is conformance way at the beginning when the data is collected before it is actually tabulated. So data is first collected, and then there's conformance checks using some tools, and then data is then tabulated, and then it's finally gone to the FDA for submission. So we have put together a lot of tools, and it has taken us 2 years, I guess, to fine tune these tools to make sure that the conformance checks are all there. And also there needs to be a lot of customization based on indications, because different indications, different therapeutic areas, they collect data slightly differently. We've also harmonized how the data is released to a dataset portal, and we have applied the FAIRification requirements for the dataset portal to make sure that the metadata tags are all aligned and harmonized. And any spot within the company or any resource that aggregates data sets in the company uses the same metadata tags, and we made sure that we have socialized these metadata tags to all the groups in the company. And so that was for data managers, the FAIR data playbook. And we also published a FAIR architecture playbook, and this is mostly for the IT community on how to design URLs, how to come up with persistent identifiers, coding standards, how the markdown languages should be consistent, and so on. So that's a separate playbook that we wrote for all the IT community as well. And a new project called Edison was launched, and this project actually follows this data playbook recommendations very closely. And you will see details about this Edison project in the Pistoia Alliance's FAIR Toolkit page. And I provided the link here. You're welcome to see this, but I'm also going to show you how it's shown on the Pistoia Alliance page. So many of you might know Pistoia Alliance is a nonprofit organization, and it's a collaboration of academia and pharma. And the reason for that alliance was there's a lot of common things that pharma companies do, and there's a lot to learn from these. So do we need to reinvent the wheel, each company, or can we share some of these ideas and do things together so we can bring out medicines to patients sooner and faster? So that's the goal of Pistoia Alliance. And one of the projects in Pistoia Alliance is the FAIR implementation project, which is how to implement FAIR rules within the pharma. And we published some use cases. I'm part of the Pistoia Alliance as well. And the Edison use case is highlighted here, and the FAIRification of clinical trial data, which I talked about at the beginning of my talk, is illustrated here. And there are other use cases listed here as well. And if you go to the method section of the same page, you will see FAIR maturity indicators for each aspect of FAIR: findability, accessibility, interoperability, and reusability. And this is what the maturity indicators look like. And we've also embarked on a project where these indicators can be quantified, and we give a score for each data set on how findable, how fair they are within the company. So all these resources are available in the Pistoia Alliance page. Yeah. And it's also listed in the paper that I talked about. So is FAIRification enough? So what we found out was that FAIR data principles are not sufficient. It's true that FAIR can tell you where the data came from and where I can find it, and it also has standardized several bits of the data using standard ontologies, vocabularies, but it cannot assure you of data quality. And there are several papers. None of this is our work, Roche work, the stuff that I mentioned here, dimensions of data quality. There are several papers in the literature that we looked at to see how data quality can be measured. And I think Shefali covered a lot of this. It's almost very similar to what has been published for EHR data. So this comes from Weiskopf and Weng. He published in 2013. I've included the citation at the end of this. So they defined 5 important dimensions for defining data quality. And then they also came up with 7 methods of assessment. And they use these methods to assess the dimensions that are mentioned in here. And I'll just quickly go through some of the glaring data quality things that FAIRification cannot help. So when you see a patient, is recorded as male and then the reproductive status is pregnant, you don't know which part of that is wrong. Is the reproductive status correct and the sex was recorded wrongly, or what was going on? Or sometimes what happens is it would say that the patient is a male and the diagnostic procedure was a gynecological examination, ultrasound of the uterus or something like that. So you're wondering, oh, which part of it is wrong? Who recorded it wrong? And it's not the job of the curator to just go fix one thing because you don't know what needs to be fixed there. So this is where it's very important to catch the error at the beginning itself. And how do you come up with rules for this, right? Something very simple, like if a patient has a fever of 100 and instead of reporting it as 98 degrees Fahrenheit, you say that it's 98 degrees Celsius, you can catch that because you know the normal range of fever and what are the units for that and what it should be. So you can define those ranges for things like that, which are quantitative. But something egregious like the patient is male but is pregnant, things like that is very hard to catch. The other problem also is that suppose you're measuring eosinophils in asthma patients, the technology that was used 5 years back is not the same as the technology that's used now. So you need to know more metadata about the technology itself to assess if the numbers are comparable or not. So there's a lot more that needs to happen beyond what I can do as a curator. The curator actually doesn't fix data errors, right? The curator is only looking at, is the data harmonized to a standard? Does this look correct based on standards? So there are a lot of these methods of assessment that are available to assess data quality, and also assessment methods depend on the area that you're working on. So cardiac, anything related with cardiology needs different types of data quality checks and assessment, as opposed to patient reported outcomes, which is just a questionnaire that a patient fills out. What types of checks will you implement for something like that, peak, or as they call it, and for cardiology, and something else like cancer, right? So there are different data quality assessment frameworks that have been developed using these as the basis. And since then, a lot of papers have come out describing more and more granular data quality methods and dimensions. And for example, temporal versus atemporal data. What kind of quality measures can we implement on this? Shefali touched basically some of this in the extrinsic data quality measures, and there is an overlap of this as well here. So data FAIRification and data quality, what are the key performance indicators? So on the left, you see that there's completeness, correctness, conformity, consistency, coherence. You can split data quality in all this. And on the right, the stars basically indicate what needs data curation, additional intellectual process of informing and correcting something, and what needs data standards. How can we fix this using standards? What can we fix using curation? And this is also from the paper. The citation is here from Weiskopf and Wenck. The left side, you see the dimensions of data quality, and the right side are the methods of assessment. And you can see that some of the dimensions can be assessed using just one method. For example, is the data current? I can just see based on the version control or log review whether the data is current or not. Whereas some of the dimension needs multiple level of assessment. So we can all, I hope I have convinced you that FAIRification, of course, enables good data management practices, and only FAIR plus data quality assessment can help give us more insights into the data. And this has been widely implemented in EHR. The data quality assessments have been done in EHR because EHR also comes with, there's no standard, right? It just comes in all dimensions and all formats and forms. Because there's also EHR where paper forms are converted to electronic records, and you have to make sure that the conversion was at high fidelity rates. So how do you combine these two? And we believe that only when you combine these two, you can have a greater impact in bringing out good data and gathering more insights. So the way we think about this is FAIRification has to be a bottom-up approach where you build the infrastructure, good data management practices, and then on top of that, you apply data quality controls to make sure that there's good governance and additional checks done on the data quality itself. And data and metadata are the raw material that enable digital and personalized healthcare. And so anybody producing data, I strongly recommend that you invest enough time in making sure that the metadata and the data are all aligned and harmonized to some standard. And we wrote this paper together, and here are the co-authors of the paper. Ian Harrow is a project manager at Pistoia Alliance, Tom Plaster from AstraZeneca, Hande from Ohio University, and Martin Romecker, who is also my manager at Roche. And I want to thank there are a lot of people at Genentech. I have to thank the whole team. Thank you, and thank you for this opportunity.